Welcome to PreVetted Podcast, a blend of tech and leadership. Our goal is to explore the journeys and stories of our guests, revealing valuable insights about engineering and business, and sharing them with our community. Our guest today is Sachin Keswani. How are you doing, Sachin? Great to have you here.
I'm doing fantastic, Federico. How about you?
I am doing great. Um, we have a sunny day. We have great food. So yeah, life is good.
Yeah, it's a nice weather today, sunny day, so can't complain.
Yes, yes. So tell us a little bit about yourself.
Yeah, thanks for the inviting me and to be a guest on your show, Federico. I had a fantastic journey. I would say I spent around 18 years in the semiconductor and AI space. Starting early on in 2004, I finished my bachelor's, worked for a couple of years in India, back there. Uh, Again in the semiconductor space, came to US. I finished my master's, and since then I have been working at Qualcomm, Intel, AMD, Samsung, back to Intel. So all the leading semiconductor companies. It's been a fun ride, I would say.
Great, great, very interesting. I just met the other day. I met the head of marketing of Qualcomm, and he was talking about the future. What are they doing and what they've been doing in terms of development, right? Of new things. Um, and basically they were telling that they are everywhere. There are a lot of scientists and people that are developing things that we use on the daily basis, and we usually don't know about it, right?
Oh yeah, very true. Yeah, Qualcomm has been doing very well. I know them for since 2006, 2008, and they have been started with mobile location. Now they are in IoT, AI, many other spaces, and computing like CPU. They are having their own laptops as well. So they have been doing fantastic.
Right, right. So let's start talking about classical computing, because today I think we can talk about classical computing versus quantum computing, right?
Yeah, sure.
um, so tell us a little bit about your experience with classical computing, CPUs, GPUs. You were mentioning about the NPUs, the neural processing units, right? um, Tell us a little bit about where is the industry heading, and how has been your experience with that?
Yeah, thank you for asking that question. So I have been very close to the computing for last 20, 30 years since my school and college days. And central processing unit mostly was the heart of any system. And as it has evolved in terms of like the wafer size or in terms of the fabrication process, we are reaching like nanometer and angstrom levels. When I say that, we are like talking 10 to the power minus 10 or minus 100 levels of a meter, much, much thinner than a human hair. And the classical computer is more like when we see and divide things in zero and one. You see day and night. But that's not how nature actually works. There's not one time when you say sunrise happened, sunset happened. It's a gradual process. So
Right.
once we are moving to the quantum space, what I'm explaining more in terms of how a layman could understand is is a probability of being in a state of zero and one. You can only never say with certainty whether you are in a state of zero or one. So it's enables have a massive computation, massively parallel computation at the same time. And that's giving it like 100x or 1000x gain over classical computing. Now, we have seen some of the early prototypes, and the industry is evolving very rapidly. And once we reach a few hundred to thousand qubits by the end of this decade, 2030, uh, there will be something called useful quantum computers. I wouldn't say they are practical enough to solve very large problems. That may happen in another 15 years or so, but you would see a wide adoption of them in the next 5 years.
Right. right. I so what is the difference between a CPU and an NPU?
Yeah, so CPU, if you see, was a central processing unit which traditionally evolved to take care of everything, peripherals, I/O, data management. And as we started into late 90s, we had a need for the graphics had a very intensive number of operations that were needed, which were more like SIMD, which I would say single instruction, multiple data. You had to apply the same instruction parallelly over multiple data streams. That's where the GPU came in, graphics processor unit, which was customized for graphics operations, much more focused and solving a particular function. And then GPUs happen to be very relevant for AI space as well because the number of operations we were doing were very similar. Now came the need that if you have a specific workload, can you develop a specific chip with specific matrix multipliers or specific functions which exactly solve that problem? So comes in picture a neural processing unit. And some companies have started including them in their earlier versions of laptops, for example, Intel. So now you see in higher end laptops a CPU, a GPU, and an NPU. And to give you one example, what when we are talking right now, if we apply some background effect like a blur, right now it is being done on a GPU on your system. But as we move forward, uh, there would be AI workloads, including these blur effects, which will start moving to NPU. So GPU and CPU are free to do other stuff. So GPU will be the new CPU. Not exactly, but I'm giving a loose analogy here. And the idea is NPU is much more focused on solving some particular workloads and is optimized to solve some functions better than either a CPU or a GPU. That's one reason. Second reason is GPUs, if you know, are very power hungry right now, and that's the biggest cost of a lot of data centers right now. It's the power and the GPU. So once you have custom silicon, that's how the industry is going to evolve in the next few years. Custom problem, custom solution, custom ASIC solutions, and that's where the NPUs, or some companies like to call it DPU, like a data processing unit. Some like to call it IPU, intelligent processing unit. They all have their fancy names, but the idea is the same.
Right, right. So it's interesting because the whole idea about the CPUs was to have a generic processor that could do any type of operations, right? Because before that, it was, you would build a very specific circuit for a very specific task, but you could not deviate, right? And the evolution of the CPU was, oh, now you can do whatever you want because now you can code it on the software level. But as you were talking about, that comes with a cost on performance and power consumption. So now we're going, 180, and we're going back to a specific chipsets for specific tasks.
So this is an alternate cycle. If you remember back from your physics days, there was a sine wave and a cos wave, There's
Right.
it goes through phases of up and down. So that's how it evolves from very big mainframes back in the 70s to very small PCs and then laptops and then mobile phones, again back to cloud. And so this kind of keeps alternating in terms of shape, size, and form.
Right.
Very small
Right.
units, from very big units of compute to very small units of compute, back to very big units of compute. So you will keep this cycles, you'll keep seeing these cycles alternating every decade or so.
Right. Right. I remember the Linux terminals that basically was a computer with just a keyboard and a remote screen to a central mainframe. Well, it wasn't Linux, it was Unix, right? And then eventually with Windows, all the power consumption came to the local computer, and then the Chromebook came in, and it was, oh no, everything, a thin computer, everything on the cloud, right? And now, as you're talking about the NPUs, we're coming back to everything on the local hardware, right?
Oh, yes, definitely. And if I'm not wrong, it's around 18 and a half years when the cycle shifts.
Right, right. And so the NPUs are mostly to use with LLMs, right?
LLMs, yes, could be one use case. Currently, it's the very hottest use case. But there could be another inference workloads, or when your companies are concerned about your data not leaving your system or about the privacy, then also it will be very relevant.
Right. So the way that I understand the CPU versus GPU is, the CPU is, one dot at a time to make an image, right? And then the GPU makes it boom all together, right, in parallel. Following that analogy, like, what would be a good way to explain the NPU, right?
Let me think of a good example. NPU is more like if I'm doing one particular set of operations or fixed functions, which I have to do repeatedly much more. It's kind of, you can say, evolution of GPU. GPU was like optimized for graphics. Same operation I have to do multiple times, but now I have much more variety when I talk about the AI workloads because it's a symbolically representing a neuron which has to do multiple calculations to and fro. So it's a particular neuron structure which you're trying to emulate here. And if I can develop a chip which specifically solves that particular problem, like for example, a transformers revolutionized how LLMs are doing right now from the 2017 paper from Google. Now, if I develop a chip that exactly is based on the transformers architecture, it's solving one very particular kind of problem. So it may not work very well in other cases, but anything which is utilizing transformer architecture, it will be super efficient, more efficient than GPUs or other chips. Just to give you one
Right,
example.
right,
Some people also like to use it, call it accelerator. You have accelerator functions. So different companies are taking different approaches in solving these problems because the architectures are evolving, the chip architectures are evolving, and there's divergence in terms of do we need to have one new architecture or do we need to have newer architectures depending on what model we are building. So you will see some diversifications, a lot more startups trying to tackle this. And for the next 4 or 5 years, it will be if there's an evolving dominant architecture, let's say a transformer architecture, then probably a chip which you develop specifically for transformer architecture would have much higher chance of success. But it all depends on how usable it is for different kind of architectures and who wins this race. Generally, the
right,
winner decides, like, which way the architectures and chip architectures evolve.
right. Sometimes the market defines rather than the most technological advanced solution, right?
Yeah, I mean, if it's Nvidia winning, they will like GPU to be used everywhere. But it's a different startup who's challenging them, then they will like more diversity and more variety, different solutions. So it all depends on how this market evolves. But if I can foresee correctly, there'll be at least 2 to 3 new players in the market by the end of this decade.
Right, right. Very interesting. So I was going to ask you about, you mentioned something early, and I wanted to come back to that. Um, what is the relationship between the size of the CPUs, and I think this happened for the GPUs and the NPUs as well, right? The size, the connection with the size and the performance, right? You mentioned we're getting to 5 nanometers, right?
We already have hit 5 nanometers in some cases. Now we are going to 3 nanometer, 2 nanometer, 1.8 nanometer, then 1 nanometer. But that limit we kind of will start hitting around 2027, 2028. And now the challenge is how we go beyond that when it comes to classical computing, because quantum mechanical effects start coming into picture then. Um,
Right.
so
Why are you is the industry trying to achieve smaller sizes?
you can fit in many more transistors in the die, and that means you can do far many more computations per second. So your instruction per cycle improves. And but there are limits to how far can we go. We are already seeing kind of the Moore's law has been stretched. And there's a parallel research going on if instead of silicon, we need to find different materials through which we can gain more performance. So performance is important, but at what cost? There comes a point when we have hit the point of diminishing returns.
Right. We're hitting the limits of the maximal physical speed, the maximal speed of the physical, um, you know, it's not cables, but conductors within the chip that are our performance bottlenecks, right?
Yes, that's true. I mean, there are different ways we have started defining performance. Is it performance per watt or like other metrics? Um, but humans have been very creative and very resilient. So they have always find ways to overcome whatever challenges they have encountered. So it will be interesting that maybe in the next 3, 4, 5 years, they are able to find some new material or achieve some other breakthroughs through which they can keep stretching these limits.
Right.
It's
Right.
becoming harder and harder, but I wouldn't say it's impossible yet.
Right. But the fundamental approach of CPUs, we're reaching the limits. We can keep stretching it, but there's,
Uh,
as you mentioned, there's so much we can go, right? And I think that's where quantum computing is starting to have an enter in the game, right?
Yes and no. I mean, in between these two, also there are a couple of steps or multiple steps. One is the chiplet architecture, which is evolving. Right now, only Intel and AMD chips, or even Samsung chips, had this chiplet architecture where instead of having big monolithic chips, you are having smaller chips. And now the chiplet architecture is actually getting extended into IoT and automotive space as well. So that's another way of stretching the life of these existing architectures. The other, I would say, is optical computing, where instead of these connections so far at the copper level, all the signals are going to use the light. So there's been a huge progress in the last 2 to 4 years in optical interconnects and optical computing. So between the classical and quantum computing, I think optical computing is something which will define the space in the next decade. So that will be the bridge.
Right.
And even when I say quantum, it's not that one fine day we'll have suddenly a quantum computer. It will be a gradual approach where we are moving towards hybrid computing. Some portions will continue to be done like the way they have been in classical computing, and some will be hybrid with there's only certain pieces which will be done in a quantum way, and slowly and steadily we will move from hybrid to a complete quantum. So
Very
imagine this as
interesting.
as an evolution happening, that it won't be like a gradual 0 to 1. It could be 0, 0.1, 0.2. So you will be like, I have a hybrid 2080, 3070, and gradually you will see.
Oh, I see. I I am amazed about the quantum mechanics,
Hmm.
right? That they're able to do this quantum entanglement of two, I believe, two protons, where they have this, they are connected regardless of the
Distance.
space, right, and the distance, right? Um, and they're thinking about that could be a good way to communicate, because that on the far end of space, because it those two elements are entangled. I'm probably I'm saying it wrong, but and then you can communicate with that faster than speed of light, right? Or that's what I understand is happening, right? um,
You are
and
right. You are right. You correctly said it. It's the photons, and they are like entangled in terms of if you know the spin of one, you know the spin of the other entangled photon would be the anti of this. So you don't need to actually communicate in between them. If you know the state of one, you will know the state of the other one, and that's
right,
like a
right.
huge benefit in terms of you're not actually sending anything. So it beats the speed of light too.
Yes, yes, it's amazing. I mean, the way that I think it is, when you have a function and you send a variable by reference, right? I think it does that way because I'm a coder, so
I'm
it
probably going off
resonates.
tangent, but some people also correlate it to consciousness, like how you communicate with the cosmos is you just communicate, and
Right,
how the
right.
probably quantum space is going to. we'll see how the future unfolds.
So I mean, when you mention quantum, I recall that type of quantum physics. So I'm wondering what is the relationship between quantum computing and quantum physics, and how much of these new properties of quantum physics are could we exploit for the quantum processors development?
Yeah, I mean, that's a very relevant question, I would say. This is actually the year of quantum. It's been declared 2025 as the year of quantum, and it's because it's been 100 years of quantum physics. So, for whatever imagine we knew back in 1925, it took us around 100 years to reach this point. So, whatever research is being done now in terms of more materials as well as architectures in the quantum domain, that's going to be even more relevant moving forward. The way you generate the qubits, like you have bits which are 0 and 1 in classical computing, you have qubits which can possibly exist in either of the states between 0 and 1, and you just know the probability. So now the qubits could be generated in many different ways. They're ion trapped, there's photonic qubits, there's silicon, and there are like five or six leading ways. And so the space is still evolving. Like IonQ and Rigetti Computing are doing one way, Microsoft is doing some other way. You saw Google and Intel, they are doing a little differently. So I would say there are like six around approaches to generate these qubits, and there are still more approaches which are being evaluated. So any new developments in the space of quantum physics would definitely help uh, this field much faster. Especially, there are still other evolving spaces like quantum communications, quantum networking, quantum key distribution, and eventually there will be quantum machine learning. So you may have to redefine a lot of what you did in the classical computing into quantum space, and it may not be very straightforward. You have to build new hardware, new infrastructure, and new protocols.
Right. Right. So so you're talking about that quantum computers they have non-deterministic zeros and ones, right? So it's a probabilistic model, right? Similar to the electrons on the latest model of atoms, right?
Mhm.
Um, Used to be what is the name? This the padding, right? The padding model, right? The we know they're here, and then eventually became this. We know that they are somewhere here, but we don't know exactly where, right?
Yep.
um, yeah, that's how I remember it, basically, right?
Or if you look at the Heisenberg's uncertainty principle, which was more like you can never say with certainty about the position and the speed of a particular moving particle, if I remember correctly.
Right,
That was back in 1920s or 30s, maybe.
right, right. Yeah, I think that's what I was talking about. Yeah, and so what is the benefit of having a non-deterministic zeros and ones, and what are the cons on quantum computing?
So the pros are like in some specific, like NP complete kind of problem. If you remember back from the computing days, like we had traveling salesman, anywhere where you have hundreds and thousands of permutations and combinations to calculate, like for logistics, for operations, like airline scheduling. These are nightmares. These needs huge amount of computation because you are evaluating many possible permutations and computations to get to your answer. So if you go about them serially or even parallelly, it still takes a lot amount of time and computation. Now, if you, for these particular kind of problems, if you deploy quantum computer, you can get to the answer much faster, maybe in a matter of minutes to what was taking them like days or weeks. I'm just giving you the scale of an example of the scale of how it. So in some specific problems, which are like NP complete problems, very famous in the computing world, it will have tremendous advantage. It may not help you in all of other like everyday computing problems that much, you know, But in certain examples, it would like especially in operations, protein synthesis in biology, um, and like when you calculate some of the properties of very large clusters in space, the data that you get from the space, and you're trying to process it for the signal and noise, that huge amount of data today takes weeks to months for space research. So those kind of problems would be very suitable for quantum computers.
Right, right. Anything where we have a lot of permutations and a lot
Combination.
of like matrices of data with multi-dimensional problems, right?
True, true. And that's why I foresee that both classical and quantum will coexist. It's not like one replacing the other.
Right,
But the biggest
right,
danger many people see right now is if there's a lot of our communication is secured by the cryptography. And that if you want to break any cryptographic protocol, there are a lot of permutation combination if you want to do it in a brute force way. And that's where quantum is way faster. So people are afraid if the classical like RSA or other cryptographic protocols can be easily broken by quantum computers, and then your existing safety protocols, like all communication is secured by these, could be challenged. So there's a set of companies which are evolving to secure your digital communication right now by saying it's as a quantum safe. So that is the next evolution, which the use case which you will see happening very, very rapidly right up in the next 1 to 2 years, even the governments have defined the protocols. So securing your communications. So that will be the first thing that might be under threat from quantum computers.
right, right. Yeah, I was going to bring that up because the issue of encryption is basically that we depend on a a so costly computation that is not worth to do, or by the time you solve that problem, the information is obsolete, right? So quantum computing can save us, instead of months, it can do it in days or minutes, right? Um,
So,
so
so yeah, I
that's
mean,
going to break all the encryption.
yeah, if you see entire premise of all the banking transactions of our communication is based that if it goes in the hands of a bad actor, it will take them months or years before they are able to get hold of any relevant communication. So it is safe. But what if that premise is wrong? That assumption is proven wrong because now they have a device which can break the existing encryption much, much faster. So that's why in the encryption space, you will see the adoption of quantum the first, or at least one of the first use cases.
Right, right. Yeah, it's usually you know it's a race that it's always evolving. We build security mechanisms, and then bad actors figure out a way to break them, and then we keep going, right?
It's a classical case of good cop and bad cop. Who gets the technology
Uh,
first?
right,
And how
right.
do they
Yeah,
use
yeah.
it?
The same thing happened with viruses, right? They keep evolving, and we try to catch up, and it's always a battle of who gets there first, right? Um, we usually think about, like, oh, the flu, right? Yeah, but the flu has been evolving every year, right? And then the meds that, the antibiotics that we take, then they don't have the same effect over and over, right? So we have to bring new meds, right? So it's a battle, right? Yeah.
Okay.
um so here's we have the same thing, right? So we need to improve the security, so we don't depend anymore on uh, on having to decrypt, having to use prime numbers, right? There has to be other ways to solve
Yeah,
the
it
encryption,
may
right?
evolve in multiple ways. It may be a hybrid of both, like some aspects of classical words and mixed with some aspect of quantum, because it may still take time to completely move on completely quantum secure communications. But I still see like banking and financial institutions adopting it the first. So that would be the most practical, and like military and defense, wherever you have communications of national importance or of prime financial value, they would be the first ones to adopt.
Right, right. I mean, I think in a few days is the RSA Conf.
It's right now
So
going on in San
it's
Francisco. It
oh,
started.
it's right now.
It's going today for next 3 or 4 days, I believe.
Yeah, yeah. I was going to go, but then I had other commitments. So yeah, but that's where they talk about this type of encryptions. Yes. um, so the other thing that I understand from quantum computing, and correct me if I'm wrong, but um, what I understand is that we could run so much parallel processing that they were able to use that as a way to prove that there is the existence of multiple parallel universes. And I was like, what?
Yeah, that's something I have heard too. I don't know how, but yes, the concept of multiverse is gaining ground as
Yes.
more quantum gets proven. Um, yeah, I still don't know how, but yeah, we'll see.
Yes, yes. And then the other thing that they did is they again I read I read that information, but I don't remember it by heart, so I'm probably missing some data. But they were able to have um, similar to quantum entanglement, but they were able to prove that a particle was changing both in the past and in the present and in the future.
Okay.
Yeah, I couldn't understand 100% what they were talking about,
Mhm.
but basically they changed it in the past and it changed in the future. And yeah, I couldn't understand completely, but basically they were able to prove that the information was traveling through time.
Oh, okay. Okay. Yeah, I'll check that experiment.
I'll find it and send it to you. Yeah.
Sure.
Um,
Love to read that.
but that was yeah that was what I read somewhere. Yeah. So how is quantum computing going to affect the performance of AI in the future?
Yeah, that's a very interesting question because I feel it will help both AI and quantum, like both, they will both help each other. What will happen is like right now, training an LLM requires huge amount of data center costs, and there is a theory that the quantum computers can help train those LLMs much faster. So AI becomes smarter, faster, and in turn, the smarter, faster AI can search for new materials or do the quantum simulations faster. So, so it's like a feedback loop where each help the evolution of the other to happen faster.
Oh, I see. I see. So with quantum computing, we can get more power to run AI, and then we will be able to see AI more advanced and in smaller devices as well, right? With less power consumption.
Well, those are two different things, I would say. Like
Ah,
one
okay.
is like being able to run inference definitely will happen, whether there is quantum or not. But being able to train these very large models, which right now need huge amount of GPUs, that probably assumption may get challenged. We might be able to even build bigger models with less resources and do train them faster with the quantum. But there's also an evolution of something called quantum machine learning, like how we do machine learning on GPUs right now. We could probably evolve it by doing qubits over quantum computers. I haven't seen that example myself, but there is one company I saw a demo who were able to train a model much faster using quantum computers. And that was a use case they picked up. So suddenly your training costs are going down. You can achieve that AI faster, AGI faster, and in turn, that can help simulate your quantum simulations or any materials that you need to build your quantum computers much faster.
Oh, I see. I see. The I was fascinated by being able to run an LLM, a few LLM on my laptop,
Mhm.
and I was, I download the models before taking the plane, and then during the flight, I was able interact with the LLMs and ask them, like, give me a recipe for a chicken, right? To cook a chicken, right? Or, um, what is um, what is bigger, what is what follow faster, a kilogram of feather, a kilogram of steel, right? And being able to have this, and I was trying to poke him on how much, logical responses I would get, right? And I was amazed by, being able to run that in a very small computer with very limited resources, right? And still being able to get very logical responses, right? So and these are the models that are easily available with one click, right? So
I think that's a challenge I see for the humans as a society or a civilization, that now you have something in your hands which has a few neurons, so it's intelligent enough, and sooner or later it will reach a point where it will have the human intelligence. And now, how do humans are literally competing with a machine which has equal amount of human intelligence. So, do humans need to step up their game, or which way the evolution happens? Like, so far, we have heard about evolution, but it's been mostly in terms of like shape and size and having a tail or not. But we are not really evolving physically, but there are still mental and other aspects of humans which probably need to evolve, because we are kind of outsourcing all the day-to-day chores and daily functions for the robots and AI to do. So what are really humans gonna do?
that is actually a yes, that is a very interesting question because there was a company in TechCrunch that was saying, stop hiring humans, hire AI, right? Your next non-human hire or something like that, right? And basically they're doing what you're describing. They're replacing AI agents, people with AI agents, right? So we're already seeing this competition. We wanted AI to do the dishes so we could do the creative things, and AI is doing the creative things while we are doing the dishes, right? So it's it's going into a very very weird evolution, right? And as you mentioned, um once they're able to evolve themselves, they're going to evolve at a much higher pace as we, right? So they're going to outpace us very quickly, right?
Yeah, but I still believe humans have been very uh, tenacious. Humans have been very creative and resilient, and whenever there's been a challenge to their existence, they have always evolved into something more. Like there was a time when they were in the jungle and we were like humans were afraid of animals. They overcome that challenge. And today, humans as a species is creating something more intelligent than themselves. So obviously, humans will figure out what will be their role in the next 100 years or so. It will be
Yes,
interesting space to watch.
yes, it will be very interesting to watch. The industrial revolutions and all of these revolutions created this new, basically, uh, the revolution means that revolves everything, and there is no within the chaos, there is no set hierarchy anymore, and there are opportunities for people to upskill and be able to grow and become something different, because what was needed before is not needed anymore, right? um, the and that evolution can happen slowly, and then boom, it happens immediately, right? um,
That's
so
what they
the
say. Sometimes you make the progress of decades in few weeks.
Right, right, yes, and we don't know where is that going, but we definitely need to be adaptive. I think that you mentioned about resilience, and there is the other component of that. I think is adaptability, right? As a species, we can adapt very quickly to the surroundings, right? Yeah. The My concern is um, the um, the iPhone has more power than the computers that they used to send, to do the Apollo 11 navigation, right? And that was Jack Black's mother that did they did the programming for that, right? Um,
And
did
now
you
we are
know that?
talking about like AI phones or AI devices which won't even have a
Right.
glass or anything, and it will just know. So
Yeah, it will just know. Yes. The but the It has a lot of power, but we're using it mostly to show ads and to become a spy of everybody, right? It tracks us. It knows everything about us, right? So we what I'm trying to say is that we have a lot of power, but I don't feel we're being able to exploit it as much as we could, right? Um, and So I'm wondering if this is going to have something similar, right? Where we could do much more, right? Or the fact that the iPhone or social networks is supposed to bring us together, but it's actually makes us more isolated, right? Isolated and lonely, right? So it's the paradoxy of that connectivity, right? Um,
so there's a saying which goes that the smarter the device becomes, the dumber the human becomes. Because your now device has all the functionality to do, so you are not using as much functionality yourself, and you're kind of outsourcing even the decision making to the device. And what are you going to do with the time which is being given to you? So, for example, the idea was productivity should go up because now you have a lot of free time. But what you're doing with that free time? Are you scrolling Facebook, WhatsApp, social media, Netflix, or are you going doing something, creating something useful, productive in that time? So the choice
right,
is there.
right. The choice is ours.
The choice is ours.
Yes. Yeah. And um the way I see it is a tool, right? You can use it to build a hammer. You can use it to build a house or to kill a person, right? So it depends on who yields the tool, right? So I think here's the same thing, right? I remember when before GPS, people were able to move around, and when Google Maps showed up, then people would start driving over bridges or unfinished roads because it would just focus on the map, right? So I think we're going to have something similar, where we're going to have a group of people that are going to leverage the tools and evolve, and some people that are going to become exploited by the tools themselves, right?
Yeah, I think it all boils down to the choice. We still have the choice. And that's what I see. Like if AI can do a lot of coding, a lot of these tasks, where would be the incentive for humans to really go and learn? Like the next generation, which is just getting into like schools, sometimes it's like, oh, I can ask ChatGPT or other AI tool, why do I really need to learn? So it will be only a matter of choice. If I want to learn, I would learn, but if I don't want to learn, I can just ask and I'll get the answer. So, how would that impact as a human? What a human's uh, cognitive functions would be like in 20, 30, 50 years from now? That's an interesting space.
Yes, yes, and we're talking about quantum computing. That's going to have a significant effect on the performance that we have available for us to run more complex processes almost instantly, right? And being able to figure out how are we going to leverage that, right?
For sure.
Yeah,
For
yeah,
sure.
yeah, yeah. Um, you can now go to online and find MIT, Harvard, and many other schools or universities. The curricula is pretty much open, right? You don't need to spend thousands of dollars to actually go to those classes, right? Albeit it's not the same as actually going, I believe, right? But it's there, right? You can do that, or you can watch, kittens, video of kittens, right? Or whatever the goofy thing is now, right?
Yeah, it all boils down to the choice you make with that free time. I mean, I would see it as a great opportunity for humans to unleash their creativity. That's what they always waited for. Oh, I don't have enough time to do this. If I wish I had this thing done, I would have maybe done more creative stuff. Now you have those tools, you have that time, but are you leveraging those tools and leveraging that time? Time, I think, is the biggest currency we all have. More than even money is the time, which is, I think, are you time rich or are you money rich? So
Right. Right.
now is
Uh,
an opportunity to be time rich, which I think will matter even more in future. Um, but what we are doing with our time is an individual's choice.
right. Right. Um, time is the only asset that you spend and you cannot get back.
Correct.
You cannot get more.
I think that's the only thing which is limited in our lifetime. Time. Everything
Yes.
else can be like infinite, including money, but not time.
Yeah, money you can make more, right? There was um, a billionaire that spent I don't know how many years trying to research how to de-age, right? How to stop aging, I guess. And um, he spent a lot of money into that and living this extreme life, eating, I don't remember, but crazy, very extreme stuff. Not crazy, but extreme, right? And then they they analyzed the cells decay, and they realized that all his experiments make them grow faster, get older faster. So it had the opposite effect, right? um, yeah. So yeah, I agree, time is the only thing that we have that we cannot get back. Yeah. um, yeah. So it's going to be interesting to see how um, you know we can get more computing power to run a better AI into our everyday life, right? Being able to have the integration, right? Uh, on Friday was Thursday. I was on last Thursday. I was on a meetup on GitHub where they talk about a agent to agent protocol and CMP, context. I don't remember what the M stands for, right? And basically, those protocols are designed so that AI agents can talk to other AI agents, right? And that is going to, basically, because right now we talk with one LLM, it's the user LLM and the word, right? And now with this, and we have these islands of knowledge, right? So, the calendar, and then your address book, and then, and then the mail, but they're islands, right? They're not interconnected, right? At least, for instance, ChatGPT doesn't know anything about that. And if you have a local LLM, uh, you know, you have to make the connections manually. So there's not a good way for to do those connections, right? So I think that's the next evolution of AI, at least in terms of, not in terms of computing power, but in terms of usability, right? On being able to have my phone and saying, hey, I'm going to this conference. Who do I know that is going to this conference as well, right?
Mm.
And oh, I have the phone number. I can call that person or send them a text. Right now that workflow is still not working because the phone is its own thing, and all its applications are their own thing, right? But if you open that, then you get into this, privacy and security problems, right? That we haven't had before, right?
And I can completely see the scenario that you talked about, that if your friend is coming to the conference, maybe you don't even need to call him. It might be your AI agent who knows enough about you, talks to your
Right.
friend's AI agent, and they set up a meeting, like look at the calendar of each other, set up a meeting time when there's no conflict and they're both going to the conference. So even that is all set up. So like it's end-to-end automation.
Right.
If let's say both of you are okay to share that much privacy and details.
Yes, yes, that's where I think it should be going, but we're not there yet, right? So being able to run a an LLM into a MacBook Air M1, which is old-ish CPU, but still plenty powerful for that type of stuff. Um,
So that's
I'm
one thing I already see happening, and I believe there's one startup or few startups which are trying, is the CPU will become relevant again, very hot again, because a lot of inference tasks, you don't need LLMs like large language models, you need SLMs, small language models, which you can just
oh
run within the constraints of your CPU and memory constraints, like on your laptops and desktops. And that would be the next evolution. Like last 2, 3 years, we have seen mostly like LLMs, but now we will also see a lot more SLMs, small language models.
right, right,
And for that,
because
CPU is enough.
right, right. They would have a much more limited set of skill sets, but good enough for the device, right? For
Yeah.
the yeah,
I mean, let's say you don't need 100% accuracy, even if it gives you 90, 95% accuracy, maybe it solves your problem for majority of the cases.
right, right. I mean I know people that use Siri
Mhm.
and talk to Siri. Please do this. Please do that. Right. But with all this progress that AI has been doing, I've never been able to use Siri because every time I want to ask them to do something, it doesn't quite understand what I want to do, right? Uh, Other than play music, pause music, so I rather not, right? Uh, but um, but when you want to do something, you cannot, right? So I'm
So that's
hoping that
one thing I also see happening much better now is what I call VUI, the voice user interface, like Alexa and Siris and all these voice assistants actually understanding humans and translating into real tasks and actions much better. Like so far, people have mostly struggled with it because they just couldn't get the conversation correctly. But uh, I think that would be the next evolution of interface. So far, the touch was great since iPhone, I would say. Now is the time for the voice as a user interface, where you just talk and the machine understands and actually does the actions.
yes, yes, the it is a it is a very inefficient interface, though, but it's great when you are on the move and you cannot type, right? Or you want to tell the computer to do something, you know. So having some logic there that allows you to tell them, do this and then this and then this and go for it, right?
That
That
has
that
been
would be
right for innovation, I would say. I have seen some like headsets or earpods which can do real-time translation in different language. If I'm traveling to some country and I don't know the native language, initially I was showing the translation, which was an inefficient process in case the other person doesn't know to read and write. So I can talk to that person in real time in their language. If I'm saying in English and let's say they speak Spanish, so that person can speak in Spanish and I hear back in English. So imagine
right.
happening free, like very fluently would be an amazing thing for humans because it's actually taking down one communication barrier, and I don't really need to learn the local language, and I can travel anywhere in the world and just freely communicate. So that to me is a very positive use of AI.
Yes, yes. I We were using the ChatGPT to write a story with my son, right? So we were driving, right? And then I put ChatGPT, the iPhone app allows you to put it in voice mode so you can talk to it. And then we start doing this. My son loves Captain Underpants, right? So we describe the story, we put my son into the story, right? And then, ChatGPT will come back and tell us the story. So we started in English, and then my son started to talk in Spanish, right? And then the AI understood, okay, I have to switch to Spanish, right? And then we kind of went back to English again, right? For whatever reason. And we didn't need to give them direction and could understand what we're trying to do, right? And it was amazing because we were having a lot of fun of just, you know, we were telling what to do in the story, like, oh, and then there is a big toilet monster that shows up, right, which is part of the canon story of the comics. And now my son was fighting with the monster, right? And the AI was telling us the story, right? It's like, and then this happens, and then we will continue the story, right? So
And that's actually you brought up a very good point. That will be the next evolution of storytelling or movie making. So far, we have
yes.
seen movies which were like broadcast, like one story which everyone watches everywhere in the world, right? Lately, they have experimented with having two or three different endings depending on which region of the world. Like some may find it too offensive, so they change the ending to suit certain audience differently, getting the feedback from the audience. And the next evolution that will happen is like you participate in the story development, and the movie is tailored around based on how you like the movie to end or which character to die, which character to live on. So they have done some experiments on this, and that's how you see when there are different seasons on Netflix or Prime Video, the story changes depending on the feedback from the users. It will become more interactive once you have the AI giving you real-time feedback. And there might be a time where each story is told to an individual or a family based on how they feel about it. So the story might be different for everyone. It may not be the same movie for everyone.
Wow, that would be
That will
amazing.
be like a two-way interactive story development instead of like just the creativity of the director or the producer. It's like real-time engagement. Let's see if how it takes off, but it's an interesting concept.
Yes, yes, that would be very, very interesting because um, you're not watching it from as an outsider. You're basically breaking the fourth wall.
You're participating in the
You're participating in it. Yes, there was in the 90s or 2000 there was a series of books where you could basically have two or three choices, throughout the story, and you would have three or four endings, right? So it would say, now go to page 27, whatever, right? No, so you could go to the left path or the right path, right? You want to cross. Do you want to walk over the beach or do you want to walk over the woods, right? And then depending on that, you would find a different situation. And it was that, but on paper, and it was very, very, for me it was very engaging. And that same concept, but with a much more interactive AI. Wow, that would be amazing. It's starting to happen in games, though.
yes.
Their games, the NPCs now, they hold grudges. They remember that you shoot their house or whatever, right?
Yeah, I think that's how it's gonna evolve into like how the games are being played. You are actually a participant in that game. It's the same way I think the movies may also evolve, live and interactive.
Right, right. Um, So I have one last question for you. We've been a little bit over the allocated time, so I appreciate it, and I apologize for taking a bit longer. If you could give one piece of career advice to your younger self or to someone listening today, what would it be?
First of all, thanks a lot, Federico, for inviting me, and it's I'm glad we were able to touch so many different points and tangents. The one advice to me would be I had actually enrolled for a PhD in quantum computing, but at that time I did not go ahead and finish it. And my department chairman also kind of encouraged me that it's more in the domain of science rather than engineering. And sometimes I wish I had pursued it. It would have been very relevant now. That being said, I still think I made good choices in terms of both software and hardware because they keep alternating in relevance. And I always been like in embedded systems in between. So even today, I feel I'm comfortable speaking software language as well as hardware language. And that since hardware is becoming hot again. Last decade was software, so it keeps alternating. So that has helped me stay adaptable and nimble and be able to move ahead with the changing times. For the younger people, engineers who are just entering the workforce or who are still going to college, um, I would say don't think that since AI is doing everything, there's no need to learn. Still, you have to learn your mathematics, coding, and build strong foundation. The language C, operating system, these things were there even before I was born, and they're still relevant today and will be still relevant even from 100 years from now. So build your foundation very strong, pay attention, and these are long-term benefits which come. Sometimes but they may not give you immediate returns, but long-term programming languages, data structures, algorithm, operating systems, chips, hardware, these are all going to be very relevant at least for next 20, 30 years.
Yes, yes, I agree. Strong foundations
And no
is
matter
very
what,
important.
we there will be mathematics always needed. So get good in mathematics, that will always help you, always.
It's funny because the when you're in college, you don't think, you learn a lot of those things and you're saying, "Oh, I'm never going to use them." And then when you start working, you realize you need them and it's like, "Oh, I should have paid more attention." Yes.
Very true. Very true.
So thank you very much, Sachin, for joining us. I appreciate the time. It's been great to learn more about semiconductors and quantum computing and to know each other, right? So I appreciate it.
Yeah, thanks a lot, Federico. It was fun chatting with you.